Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 7 to 9 word search. It's a medium difficulty grid problem, and we're going to be using a m by n grid of characters, board, and a string word, and we need to return true if the word exists in that grid. So the word can be constructed from letters or sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring, and the same cell may not be used more than once. So in this example, the word is A, B, C, C, E, D, and it does exist in our board. In this example, it also does. In this example, our word is A, B, C, B, and that doesn't exist in our board, so we return false. We're also given some constraints. We're told board and word only consist of lowercase and uppercase English letters. So the kind of approach we're going to be looking at today is a depth-first search approach, but specifically a backtracking depth-first search approach. We have to check each permutation, each combination of potential paths to get a word that's made up of those cells or values in those cells. So let's hop straight into the code. Let's get rows and columns equal to length of the board and length of board 0. So this is going to be the number of rows and the number of columns in our board, and we want to create a set called path, and path is going to have is going to store all the paths that we're currently at. So that means we don't keep going to the same path in our depth-first search function. So let's now define our depth-first search function. We want to take a row and column, as we always do, but we also want to take I, which is going to be the depth or the length of our path so far. And our base case, we want to set our base case if I is equal to the length of the word. Well, in that case, we found the word in our board, so we not return false, we return true. And then we will also want to have another check. We want to check, are we out of bounds, or is our path in, or is our path in is our row and cell coordinate in our path set, and if so, we also want to return false. So let's get straight in. If we're going to say if R is less than 0, or C is less than 0, or R is greater than or equal to rows, or C is greater than or equal to cols, and let's check for a tuple in paths, or word I does not equal to board R C. So if the word that we're supposed to be at I does not equal to the character at the board, row, and column, well then we know that this path won't give us our word, so we're just going to return false. The next thing we want to do is actually add that tuple, so add our path tuple, so our row and coordinate, and then we can do depth-first search. So we can say our result is going to be equal to depth-first search, row plus 1, C, and then I plus 1, and we can do or because it could be any of the combinations will give us the correct answer. Let's say or, and then we're just going to change. So this is going to be -1, this will be +1, this is going to be right, and then we want to do left as well. It's going to be a left direction. Okay, so we've got our result now. Then we want to remove our current row and coordinate from our path so that we can do backtracking. And then we want to return our result. So now we've got our depth-first search function written up. We can now execute it for each cell in our matrix or in our board. So for R in range rows and for C in range columns, we want to say if depth-first search past the row and column and 0, if we find our result, then we're just going to return true. Otherwise, we'll go on to the next occurrence or the next cell, and we'll keep checking. And once our for loops finish and we don't find a word, well, then we know that our word isn't in the board, and we can just return false. So let's submit our code. Let's check it works. And paths is not defined because it's path. So that's a naming error, and we get an issue. Let's look through our code. Why we're getting this issue? We're getting false, but we are expecting true. So, okay, this is fine. Equal to called RC is in path or word. I does not equal to board RC. Turn false. We add our path, and then we're looking up, we're looking down, looking right, and we're looking left. So this looks good to me. Oh, we need to remove. We don't want to add, we want to remove for backtracking. We don't want to add again the row and coordinate. That would just make it worse, wouldn't it? Let's check our code works again. Now that would fix that. And it does. We pass all 88 test cases. So in terms of type and complexity, it's a bit of a long one. It's m by n times by 4 to the power of k, and space complexity is O of k. And k in this context is the length of the word, or the depth of our path. So I hope this video made sense, guys, and I'll catch you in the next one.